animals at that table, please? Thank you. All right, how do we go about a problem like this? Okay, the first thing you'll notice is you have two reactants. You've got 28 grams of nitrogen and 12 grams of hydrogen. Okay, so you got 28 grams of nitrogen that goes here, and you got 12 grams of your hydrogen, sorry, right there. Now, the first thing you need to figure out is which one limits the reaction. To determine which one limits the reaction, can we compare grams to grams? Can we just say, which one's less? Hydrogen? No, we might get lucky every once in a while, but you can't do that. So instead, what do we have to convert the grams to first? Moles. So you convert 28 grams of nitrogen into moles. So we got 28.0 grams of nitrogen. And there happens to be in N2, 14.01 plus 14.01 equals 28.02 grams in 1 mole. This is just a coincidence. This is just a coincidence. This is the molar mass. This is what's given. And this is what we want. This happens to be a coincidence. So if we cross multiply, we're going to solve for x. X is going to equal approximately what in this case? Approximately 1. You cross multiply and solve for x. Hey, do you want to talk outside and talk to yourself, please? Thank you. All right, the next thing, hydrogen. That means we got 1 mole of nitrogen. We have 12 grams of hydrogen. Got to convert that into moles of hydrogen. So to do this here, here's the work. You got 12 grams. You want to know how many moles that is? 2.02 grams is equal to 1 mole for H2, because that's the formula for hydrogen, H2. So we cross multiply, solve for moles. We're going to get about 6 moles. Okay. Very close to 6 moles. Yes?
Why don't you put the 3 on each side?
You don't want to include the 3 here because this is the molar mass, which is the grams per 1 mole. So if you wanted to do extra work, you could do 6.06 grams in 3 moles, right? It would be the same ratio. So when you do molar masses, you do it per 1 mole. So I save some time by only doing the formula only. Yeah. Question? It's okay. Good stretch. All right. Nice stretch, Kevin. Thank you. All right, now, if you compare these two, one's moles of nitrogen, one's moles of hydrogen. Okay? Are nitrogen and hydrogen the same thing? No, they're not. So you can't compare them because they're not the same. So what we can do is we can take the 6 moles of hydrogen or the 1 mole of nitrogen and convert it into the other. So you can flip a coin or choose one. Which one would you like to do, nitrogen or hydrogen? Nitrogen. Sure, why not? So nitrogen, you've got 1 mole of nitrogen. You want to know how many moles of hydrogen you would need to react with 1 mole of nitrogen. So to know that, we need to use the mole ratio, nitrogen to hydrogen. So in this equation, what's the number in front of hydrogen? 3. What's the coefficient in front of nitrogen? 1. So 1 to 3 is to 1 to x is to 1 to 3. So x has to equal what? 3 moles of hydrogen. If you need to cross multiply, you can. X equals 3. Now, you notice you have 6 moles of hydrogen and 3 moles of hydrogen. Which one is the amount you actually have in the problem? 6 or 3? You actually have 6, because that's what was given in the problem. If you had 1 mole of nitrogen, you would need 3 moles of hydrogen. So you need 3, but you have 6. So you go to the store to buy a Subway sandwich and it costs $3 and you have $6. Do you have extra money? Yes. So this is called excess. Now, the nitrogen would be called your what? Your limiter, your limiting reactant. So nitrogen is the limiter because you need only 3 moles of hydrogen per 1 mole of nitrogen in this reaction. Now you'll notice the grams don't matter. You have to convert it to moles. And even then, the moles don't necessarily matter. Even though 1 is less than 6, here I've got 6 is greater than 3. So I keep following the 3, I go all the way back, I find out where it come from. It came from nitrogen, that's my limiter. So that's how I determine the limiting reactant. I compare it to the other reactant and see which one is going to limit the reaction. Now, once you have the limiter, the next step is to determine in B how many grams of this you have. So once you have the limiter, it's like the mole tunnel. You've got 1 mole. Let's use a different color here. We'll use purple for part B. You take the limiter and convert it into moles. So this is even easier because you got 1 mole of N2. You want to know how many moles of NH3 that is equal to. Thank you. Corey. Wolverine Center, sir. So, all right. So the next thing is, what's the ratio? What's the number in front of N? N2. 1. What's the number in front of NH3? So it's a 1 to 2 ratio. You cross multiply. X has to equal what in this case? 2 moles. To convert it into grams, what do we have to then do? Use the molar mass. So in 1 mole there are 17.04 grams of ammonia. Cross multiply. 2 times 17.04 equals about 34.08 grams. And that is our final answer for part B. Part A is nitrogen. Part B is 34.08 grams. So those are the steps you would have to do to solve a limiting reactant problem and a stoichiometry problem. This is both together. Raise your hand if you have any questions or clarifications on this right now. And if you use the, it's called the choo-choo method, that simplifies all this, all the math down a little bit. But if you use this method, this is the way it would look. Any other questions, clarifications on where any of this came from?
How many questions are there going to be on that part?
FR2, 1 for most people. Yeah, you and Kevin do it. I'll give you a harder one. Yes? 17.04 gram, that is the mass of NH3, that formula. So 1 nitrogen and 3 hydrogens, the molar mass of NH3. Other questions, clarifications, where the numbers come from? There's a lot of numbers up there, I realize. Alright. Yep.
Is there any simpler way?
No. Well, if you use the choo-choo method, it's simpler. Would you like to do that? Okay, now, the choo-choo method I like a lot. It's a lot simpler, especially for these type of problems. Let me see if I can get another slide up here. All right, so you got 28 grams of this, and you got 12 grams of this. Okay, so what I do for the choo-choo method is I make a big assumption. For choo-choo method? Yeah, it's called dimensional analysis choo-choo method. So I'm going to assume something, which will either be right or wrong. So I'm going to assume if N2 is my limiter. I got 28 grams of N2. Using a choo-choo method, you do a little train track here. And the key is you want to have your units be the same on the top and bottom. So I've got grams of nitrogen. I want to convert grams into moles. So in 1 mole of nitrogen, there's 28.02 grams. That's my first conversion factor. Once I have it into moles of nitrogen, I then am going to convert it into moles of NH3. So I'm going to go from here to here. I'm assuming that that's my limiter, which is either going to be right or wrong. Then, in 1 mole of nitrogen, based on the equation, there's my 1 up here. There's 2 moles, which is over here, of my ammonia. So there goes 2 moles of NH3. Now I got moles of NH3. The next thing I can do is I can take my moles of NH3. If I have 1 mole of NH3, the molar mass of that, add up the N and the 3 H's, 17.04 grams. So this gives me the grams of NH3. So that's the whole answer to B, if N is my limiter. If N isn't my limiter, then I would just have to change the numbers so that it fits H. So how would I do that? Well, I just set it up the same way. 12 grams for H. There's 2.02 grams in 1 mole. Okay. H has 3 moles of H2 is proportional to 2 moles of NH3. And then I've got 17.04 grams, 17.04 grams is still equal to 1 mole. So you'll notice I just set it up twice. I haven't hit my calculator once. I haven't done any math at all. No algebra, no calculation. Now, the cool thing about doing it this way is if you have a calculator, which I used to have one, if you have a calculator, all you have to do is multiply what's on the top and divide by what's on the bottom. So in the top one, you just take 28 times 2 times 17.04, and then divide by 28.02, and this equals 34.05. So let's see if I can find my pen. 34.05. Now I do the same thing for the bottom, because I don't know which one my limiter is. 12 divided by 2.02 times 2 divided by 3 times 17.04. And the answer I get for the bottom one is 51.12 grams. Now, you set it up. If you knew which one was the limiter, you just do it. Now I got grams of product. Which one made less? Was it the nitrogen that made less or the hydrogen that made less? Nitrogen. So that's the one's my limiter. It made less product. So this is my answer. That's my limiter. We're done. So that's another way of doing it. Yes, sir.
So you like do 12 divided by 2.02 times 1.
Yep. 12 times 1 times 2 times 17.04 equals, and then divide by this, then divide by that, and divide by that. The ones don't matter, so you cannot get those in. The way is your way. Now, the reason this works, it is the reason this works is this is also called unit cancellation. Let me find my stinking thing. You don't see it. Find a different color. So on this here, the grams cancel here. The moles of N2 cancel, the moles of NH3 cancel, and you're left with grams at the end. This one, the grams cancel, moles of NH3 cancel, and you're left with grams at the end. So this is a way of converting when you have lots of conversion factors. It works really well with stoichiometry. It really is just the proportion method. You take out all the algebra, this is what you would get. So another way of doing it. Now, since we've looked at a couple ways of doing a problem like this, I'd like you to solve a problem like this here. So, this is almost the same as the previous problem, except it probably is different. I don't know how it's different. Same equation. Same equation, same molar masses. So you can use previous information to help you out. And I'll even write the information that you should have had from your previous problem up there. So I'll write the molar masses of each of the chemicals up here. So you don't have to calculate those. And if you're not sure what to do, just raise your hand. I'd like to help you now before tomorrow's quiz. Lots of ways of determining it. This is ammonia. That's ammonia. So it's grams of ammonia, it's grams of ammonia. If you compare the two, this one would be the one which is 8 grams of hydrogen. All right, ladies and gentlemen. Kevin, you ready? Yeah. All right. Carrie, you ready? Good? Good? We good? We good? All right, teachers, if you're explaining it to somebody else right now, just pause for a moment. Kevin wants to say the answer?
Zach also wants to say the answer.
Kevin and Zach want to have a little peanut gallery over there, so we'll let them have fun. Let's change the color of our pointer to red. All right, so we got 42 grams of nitrogen and 8 grams of hydrogen. And we know the molar masses. I'm just going to put those up here so I don't forget them or write them down incorrectly. Okay, some people like to do this for every problem. You don't have to. Sometimes you don't need a molar mass in a problem, so I usually don't do all the molar masses, but in this one you do. So you got 42 grams. So for 42 grams, you can convert that into moles of N2. Right? Then you can convert the 8 grams into moles of H2. Then to make it easy, I'm going to convert the moles of N2 into moles of H2. Now the thing is, now you have 2 different moles of H2. What you have is up here. What you need, assuming the amount of nitrogen, would be down here. So now you can compare what you have to what you need. So the first step here is to take our 42 grams and convert it into moles of nitrogen. So we take 42 divided by 28.02. This equals about 1.5 moles. Does anyone need to know how to do that step there? Okay, we've mastered that. Okay. Then we do the same thing with the hydrogen. 8 grams divided by 2.02. That equals 3.96 moles. Okay, now we got 1.499. This is another shortcut some people like. I'm going from nitrogen to hydrogen. So what I want is hydrogen. I want hydrogen. So I put that on the top. What I have is nitrogen. I put that on the bottom. I then take this number and multiply it by 3 over 1. 1.499. 1.499 times 3 is 4.497. So, based on 42 grams of nitrogen, if I have 42 grams of nitrogen, I would need 4.497 moles of hydrogen to react completely. Do I have 4.497? No, we do not have that much. So what I need is greater than what I have. So I do a greater than sign here. That means the one that my arrow is pointing at right here is the limiter. So hydrogen is the limiting reactant. That's all I had to do for limiter. Now, once I have the limiter determines how much is produced. So, my limiter is this 3.96. Be careful, don't use 4.497. Okay? That's a theoretical amount if you used 42 grams of nitrogen. So, we have 3.96 moles of H2. We want to convert that into moles of NH3. Using the quick trick. I'm trying to get to NH3, so what number goes with NH3? 2. I'm coming from hydrogen. What number goes with hydrogen? 3. So you multiply the number by 2 divided by 3. 3.96 times 2 divided by 3. 3.96 times 2 equals, divided by 3 equals. So this should equal 2.64 moles of NH3. And the last step is to get it into grams. So I'll show you the old-fashioned way. The NH3 is equal to X grams. 1 mole is equal to 17.04 grams. Cross multiply. And the answer we get is 44.9856, which is about 44.99 grams of NH3. Yes?
So there actually is 2 ways to do it. You can find the limiter and the amount of grams at the very end.
Yep.
By based on like how much less than.
Yep. Yeah, to find the limiter, it's either the limiter can be defined as the 2 most common ways are whichever one produces less, or whichever one of the 2 has less than needed by the other. So you can compare reactants to reactants, or just do 2 tunnels to the end. Yes?
I'm kind of confused on what you did on some, like how we got to series first. Especially like the second half. I don't really get where you got to the 2.64.
Okay. So to get the 2.64, where we got that from is we had 3.96 moles. And we wanted to find out how many moles of NH3 that would be equal to. The hydrogen has a 3 in front of it, so that's where that came from. And then the ammonia has a 2 in front of it. So when we cross multiply here, 3.96 times 2, and then we divide by 3, and that's where the 2.64 comes from. So I happen to do it using this little trick right here. I just did the ratio 2 to 3 and then multiplied it through. Yes, sir?
I did the 50 method and I got 17.
You got 17.02 is the answer?
Yeah.
So you had the wrong moles of ammonia. So you may have to check your mole ratio and make sure you had a 2 to 3 ratio, not a 3 to 3 ratio. And you check it, you look at your choo-choo, and you look and make sure you have all the correct ratios in there. And you didn't make a mistake or forget to divide by something. Those are ways of checking your answer.